so that you can go back to it after class. And for those who can't be at class, all right, we have to try and cater for them. So
Sir, sir,
yes.
are there any mark schemes to put in the lab books like for bio?
Like for bio. Mark schemes, of course, there are mark schemes, but I don't know. The thing about it is I have them electronically. But I guess when I go back face to face, we'll sort out that part. But if you send your labs though online, I can mark them online and I can put the mark scheme in them. All right.
Sir, I'm just sending the pictures to you through WhatsApp. Is that okay?
Yeah, you can. All right. You can. All right, let me see something. Let me go back to F11 here. All right, so that's streaming. All right, guys. All right, just trying to start this thing off. All right, we're good now. So all right, so now qualitative analysis, guys. Right. So it is this. What you're seeing here, qualitative analysis is that the separation and the identification of elements and ions. All right, that's what we're doing here. All right, we should do at least 2 experiments in this category for CXC. All right. So that means when they come to moderate the labs, they want to see experiments from across different topics. And qualitative analysis is one of those topics. It's a compulsory topic as well. So expect that in the exam you will get a couple of these questions. So all you're doing in this is just you should be able to separate and identify elements and ions. Now CXC has a list of ions and elements that you're supposed to know. Now this is all about testing. You need to know the test for each ion. So like so for example, test for various and we start with the ions. So and the common ones. All right. Now the common ones for CXC purposes will be, I won't put them in a category here. Al, that's the aluminum ion. Then we have Zn, and then you see, when put these together, Ca2 plus, and of course, there's one more that we're missing here: aluminum, zinc, and lead, of course. How could we forget lead? All right. All right. So out of these, I think this is what them saying most time. All right. So these now, guys. Are usually white uh in their compounds. All right, so yeah, usually white in their compounds. All right, so that's the idea here. Now I'm saying common. The idea here is that when you use color with qualitative analysis, you're going to separate and identify, but you're going to identify using, all right, you're going to identify using, if you're looking here, you're going to identify using what color. Let's say color of PPT. Now PPT stands for precipitate. This is like a suspension that is formed when you mix two soluble things together, and you suddenly see a color forming, and that's called a precipitate, because a precipitate does not dissolve, right? And so when it doesn't dissolve, it tells you that something is being formed, and then the color of it lets you know what is being formed. All right. So it'd be nice to actually show you a video for that. Let's see if I can. Well, I do have a lab prepared here, but to go into video mode here. Let's just show you what a precipitate is, and because you probably wouldn't have seen this before, and some interesting ones here. All right, so let's just go here. All right, so in a few seconds now, you should be seeing an example of precipitation. All right, so all right, I think that's in there. Some creative stuff here. All right, let me just switch the screen, guys. Show you this. All right, but it's in the screen.
Yes, sir.
Yes, sir.
All right, good. All right, now let's hit play. Let's hear what this guy is saying.
Or more appropriately, double replacement reactions are a beautiful type of chemistry. Two solutions are combined and a quick exchange of partners occurs, creating an insoluble solid that falls or precipitates to the bottom.
For the digital scale.
Digital scale, yeah, digital beam balance. All right, go ahead. All right. So yes, it's just creating his solutions. All right, look at this now, guys. He actually showing you what he's adding here: copper sulfate plus sodium hydroxide, and we're gonna see a beautiful reaction here. Let's see what happens here. Everybody seeing what's happening there? All right, it's another reaction now. Again, we have a silver nitrate and potassium chromate. All right, notice that we're adding two colorless liquids together and we're getting some color, some precipitate forming. Everybody seeing that?
Yes, sir.
All right, so that's what we're gonna try to do today. That's pretty much what precipitation is. All right, it tells you what is reacting, and that looks like an iron based reaction. You know, when you see that reddish brown color, it's usually iron. And again, we have another iron reaction here, red brown. All right, so it just looks just like blood, and that's why blood is red, because iron is in there. So when we start to do qualitative analysis in detail now, you're going to know which element give you which color. Here's lead nitrate and potassium iodide here, getting that yellow color. All right, so lead iodide is yellow. All right, so these are common things that CXC asks about. So we have to be able to explain it. All right, so when you switch over again now, guys, I think that's pretty much. So you should just understand what precipitation looks like. All right, so all right, so when you just change the screen now, and it should be here. All right, guys, so any questions so far?
Yes, sir.
All right, so not hearing from persons here. I wonder if them really in class. Is Jonathan there? Is Rachel? Is Sashay there?
Yes, I'm here.
Oh, very good. Jonathan is there. Good. Is Sashay there?
Yes, sir.
Very good. All right, let's go. All right, so now, guys, remember now, qualitative analysis involves separation by precipitation. That's not a rhyme there, but it's actually true. Separation by precipitation. All right. An ion. All right. So add an ion that will precipitate one substance, but not the others. All right. This comes from experience with chemistry, guys. So you'll get there eventually. All right. Identify by color. That is the most common type of question CXC going to ask. And then what I was doing before was telling you, all right, back to this one. If a substance is white, we're going to guess that it's one of these four in there. But do you understand that? Right? You should know what. I'm saying that if a substance is white, it's one of these four things in there.
Sir, as in there's something on the screen because I'm not seeing.
Well, there's something on the screen. Everybody seeing the screen? You seen the
No.
screen?
No, sir, it's black.
No, sir.
Really? No, so. No, so something.
Okay, so we're seeing it now.
You seen it
It's
now?
gone again.
It should have gone. All right. Let's go back to this one. Well, I don't know. It's sharing at the moment, so I don't know why you're not seeing it.
Sir, it's back up now.
Okay. So I'm saying now, all right. So the point I was trying to make, guys, is that if it's white, it's one of these four that will be in there. All right. What was the AL stand for again? AL3 plus?
Aluminum,
Yes. So we're right. Aluminum. What ZN stand for?
zinc,
Zinc,
What CA stand for?
calcium,
calcium,
And what PB stand for?
I think lead.
All right. All right. So those are your common white ones. No, for different colors now. All right, we have, well, let's see. If it's blue, it's copper. So Cu2 plus will have all right, so and Cu is copper, by the way. So usually it forms blue compounds, blue colored compounds. All right, blue colored compounds. All right, so that's copper. All right, now what else we have now? We have iron. We have two types of iron. So we're gonna go with Fe2 plus. All right, and that's green.
Sir, how would you know the difference between the iron 2 and the iron 3? Like,
Because they have different colors. So
no, sir, like the chemical formula, is it different? Oh, yeah, that's
yeah.
what I'm talking about.
Yeah, so we have iron 2 and we have iron 3, right? So remember, there are two types of iron, guys. So let's write iron, not iron, but iron. I know the students make this annoying mistake of calling iron. We leaving out the R. But it's iron. It's iron 2, and this one is called iron 3. All right, so there you go. And this is usually red brown. Or red, yeah, red brown. So green color as well as red brown color compounds. All right, so this is just a general introduction, guys, and these are the cations, by the way. These specifically, these ions are cations, so we have to know it for both cations and anions. And in recent exams, CXC has gone in the direction of the cations. Not the cations, the anions, because students tend to know the cations because there are not many and they're easy to remember. And so iron 3, iron 2, copper 2, and all of these, it's easy to know them because you just need to know white, blue, green, red. And once you know those, you basically you lock all of the cations that CXC going to ask you. All right. So just know these. These are the colors associated with each ion. So if I were to show you some compounds now, you could guess which one of these is in it. All right. So if I show some white compound, which by the way, I should also add to the list of the white compounds. So they this is not writing. Strange. Yeah, the list of the white compounds here, we could also add like group 1. So we could also add sodium and potassium to it as well. Those are white. usually are colorless. But then we'll just stick with these. All right. So guys, from this alone, you're supposed to can tell me the color of each of these ions. All right, and we'll move on from here. Any questions here, guys?
No,
No,
sir.
sir.
All right, good. So let's scroll and seeing there's some other information here. All right, up here let's talk about by means of color, reaction producing color, colored ions. Again, they're copper 2. Well, green could also mean chrome. Well, at CXC level, we don't need to know this at CXC level. This is at like more at CAPE level. So CR3, CR4. Well, chromate is yellow. This might be useful because CXC have a wild question with them will throw every now and then. The chromate ion is yellow. And then of course the chromate. So we actually have chromate and chromate 7. So these are two different. Let's write the name of it here. This is called chromate, by the way. All right. And this would be chromate 4. Because the number 4 comes from the chromium when it crosses over here. All right. And this is chromate 7. CrO2. CR2O7 is actually the chromate. So this might be chromate. Chromate 7. All right. This is again not important at CXC, just extra knowledge. Manganate. This one is you going to see this a lot. Manganate is MnO4, but it has violet color. They leave off the T off it. Violet is manganate. We'll show you this in another time though. And then now what we have here beside it, nickel is also green. So let's cross out that because well at CXC they don't ask that. Also we have this looks to be manganate. We have manganate 4. This is manganate 7. MnO4 here is manganate 7. Let's make the difference here. You see, some of them ions here have numbers, guys. Not required to know them at CXC. However, in other labs, they will use these compounds. That's why I'm giving you the names here. All right. As a matter of fact, this one is dichromate. And then you have chromate. So there you go. Dichromate. And let's remove the number here. If I'm going to say dichromate, to know which one I'm talking. So we don't have to put the number for this one. All right. So there you go. So we have manganate, which is violet here. And of course, cobalt. This one is cobalt, which is pink. So this has been an older CXC papers. Manganate 2, the manganese 2 plus here. This is manganese. So these are elements on the periodic table that you probably wouldn't know because they're after the first 20. So manganese, I believe, is 20, should be 25, right? And chromium is what, 24. So, all right. So they are called what? Transition metals. So ions have transition metals. And then, all right, so then those are the colors we wouldn't need to know. But then the simple ones are here. Let me just scroll down so you can see that. I showed you these, the whites, the blues, the greens, and the red brown. This is at CXC level. So let me point out that this is CXC level. And of course, this now is a little bit above CXC, but they have mentioned these in CXC. So we just want to be aware of it. All right, guys. So the chromium and the manganate and the cobalt, they have asked those occasionally. All right. These are wild cards. All right. So as I say, guys, qualitative analysis is a beautiful form of chemistry, where you just learn why certain colors exist. Right? Colors tell you what is present in something. So just like how when you go to the doctor to do a checkup and then they take some of your urine, they could know what is in the urine based on some color changes. All right. So that type of thing. All right. So that's that, guys. Any questions here?
No, sir.
No, sir.
All right. No. I will I will send you the write-up for this lab because this lab in particular is testing for chloride ions. No, this one is for the anions. So I'm gonna give you the test for the anions, the lab for that first before we go to the cations one. But we must be able in the next couple of weeks to be able to test for all of the ions, the cations and the anions that CXE will ask about. All right, no. So I'm gonna send you this afterwards. All right, so you can follow it. All right, so this now, guys, would be a lab 7. Because according to Kimberly, you have 6 labs already. Should be done. But this one will be marked for ORR and also AI. And then this is a compulsory lab. Today's date, we're going to put as the 13th of the 4th, 2021. All right. Now, the aim is to identify chloride ions in aqueous solutions. And the apparatus when use for this is the app. In fact, I'm going to move across to the screen and show you what the app look like. All right, let me just change this now. All right, guys, seen anything?
Yes, sir.
All right, what is it you're seeing?
A lab.
Yeah.
You're seeing a lab. All right, no, this is like it's a virtual lab, right? So you can see here, it looks like a real lab. Only thing it's virtually, and you know you can go around in it to see we have a sinks here, and of course cupboards and all that sort of stuff, right? So if we can't be at school to do the lab, we have to carry the lab to you guys, and so that's what we're doing here. All right, now this now, guys, you're seeing something that's blinking on the screen, right? Everybody seeing the blinking objects?
Yes, sir.
All right, what objects are blinking?
Sir, table salt and what looks like a spoon.
It's a spoon. What's the correct name for the spoon?
Petri dish.
No. So
Don't know, sir.
what is called? We see the finger pointing on the screen. What's that called?
Mm-hmm.
Don't know.
All right. It's actually called a spatula. All right. So it means that you guys didn't get enough lab practice due to this COVID. But anyway, so you can still write that down. Now we write that down on the apparatus because it's not there. All right. So guys, all right. So we're seeing the table salt, which is NaCl, by the way, sodium chloride, and then the spatula here. And how this app works is that you bring, well, it's when it whenever something is blinking, it means that that's the step that you're required to do next. And so let's look at the instructions that's given here. All right. Do they say we're testing for the solubility of water? But then what the instructions here? Everybody seen the instructions here?
Yes, sir.
Yes.
All right. What does it say?
It says place a small amount of the salt in a test tube using a spatula. Then add 1 to 2 milliliters of water. Then shake the test tube well to test the solubility of the salt in water.
All right, very good. I hope everybody's seeing that, and that's what we're gonna do, right? So we're gonna test the solubility of the salt in water. All right, so I'm gonna get a zoom on this now. All right, we're seeing the spatula here. We're gonna carry the spatula over to the salt, and we're gonna capture it. All right. Now this screen comes up asking you what is the shape and the color of the salt. We know what does the salt look like? Is it green? Is it colorless? Is it yellow? Which one of these colors it look like?
Sir, I would say colorless.
You say colorless, yeah. As table salt is colorless, and this is salt that you use at home in the kitchen, so should be colorless. You might say it's white, but chemists say it's colorless, so that's what we're going with. So when submit this response, all right, so that's colorless, guys. All right, and we look forward to the next step. All right, what we usually do here, and after this is that when as I said, so we'll put it in the spatula and notice that the test tubes are blinking now, which means that we should move the spatula in or over towards the test tube. All right, and it's in the test tube now. What's the name of this device holding the test tube?
Test tube holder.
Yeah, okay, test tube holder. Yeah, we'll accept that. All right, so the test tube holder is here, guys. And as you can see here, it's blinking because we need to add water to it to dissolve it to see if it dissolves. And we add it to it, and it's supposed to be swirled here, and it dissolves. All right, so is salt soluble in water or is it not soluble in water? That's the question here, guys. Which one of these? You're gonna go with soluble. Yeah, definitely salt is soluble in water. All right. But everybody else is following this one. All right. So so now that has dissolved. Let's go to the next step. And did say here. All right. So something else is blinking, which means that once we see that it dissolves in water now, this is requiring us to discard of it because we're not going to use this. And as a rule in the lab, anything that we're not using, we should discard of it so that it comes out of the way. So we place it in there. So we remove that now, guys. We already see that salt soluble in water. So what you would do here is write that in your observation that salt dissolves in water. All right. I'm gonna give you that on the lab sheet in a second. And as a matter of fact, let's switch over and show you what's happening on the lab sheet. All right. Anybody seeing this?
No, sir. Yes.
Not seeing it? Not seeing it?
Oh, no,
I'm
sir.
seeing it now.
Okay, let's wondering what's happening. All right. So yeah, here it is, guys. So we're following this method here. All right. We did a salt and we saw that all right, it dissolved. So we did the solubility test. We observe it first and we see that it's colorless crystals. Solubility test, we put water and salt. We expect that it will dissolve. So that's ticked off because all right, we did it. Observation there is that salt is soluble in water. That would go in your observation. So all of these observations, guys, you're not going to write it like how you see it in the lab here. You're going to ignore it and just put the observations in the observation part of the lab, which is around, well, it's going to be around here. I should copy that observation. Yeah, let me copy the observation shortly and show you how I want it to be written. It's going to be here. Go across here. I think is this one. Yeah, and here it is. All right, let me copy these pages over. Yeah, what's the appearance of the NaCl? All of these here, you get a mark for filling these out. So let's copy it and put it over on this page. All right, so your observations will actually, all of them will be placed after the method. All right, so, and there it is. All right, so the observations come after the method. All right, guys, so any questions here, guys?
So remember to add the spatula to the apparatus.
All right, so that was added already, so it's up there. And again, that was added. All right. So this is it. We're at the step. This is the third step. The next step here, which is number 3, is when to test how it reacts with sulfuric acid. All right. And the instruction says to place a small amount of salt in a test tube by the spatula, then add drops of concentrated sulfuric acid, then moisten the glass rod with ammonium hydroxide, and then hold it at the tube's nozzle. So the nozzle is the top part of the test tube. We just want to hold the rod there. So I want to go back over to the virtual lab now, guys, and show you what that looks like. All right. So if you have any questions, you feel free to ask. All right. So we're going to do the salt test now, guys. Bear in mind, there's some precautions here that I should have recorded it. All right, I'm gonna record the precaution in a minute. But there's a caution when using sulfuric acid and salt, guys. When you add sulfuric acid to salt, there's gonna be a violent fizz there. All right, it's gonna be a violent fizz, and so if you're doing this lab in real life, you warned of that. All right, no, again, spatula and salt are highlighted here, and we take some of the salt with the spatula, and we're gonna put it in the test tube once again, guys, and then it's added there. All right, then now typically the next step would be to add the acid. So let's go and see if we can click that. And I think this is time-based, so I guess you have to wait on it to select there. All right, so we're seeing that the sulfuric acid is blinking, right?
Yes, sir.
All right, remember, guys, the formula for sulfuric acid is H2SO4. All right, and anybody doing chemistry need to know that sulfuric acid is one of the strongest acids we use in chemistry, certainly at the CXE level. All right, so sulfuric acid why we're adding it though is that it should cause chlorine to be removed from the sodium chloride, and so it's what we call an oxidizing agent. And in this case, it's gonna be a reducing agent though. I won't talk about that another class though, but it's gonna release the chlorine, and so that's why we're gonna use it. So let's see if we can all right, so we have to go towards the acid. And remember, when you're using the acid in real life, we would need gloves. But we're gonna add some acid here. I don't know if all right, so we're gonna add some of the acid using the pipette. So we're gonna add that to the list of apparatus as well. The pipette is that thing you squeeze. Oh, it's actually there already in the lab, so no worries there. All right, guys, so we're seeing that this thing is blinking. Let's get this screen up. It's at eye level now. All right, so everybody seeing the dropper or the pipette and the test tube there?
Yes,
highlighted.
Yes, sir.
All right, so we're gonna zoom in and carry the acid over towards it. You should see something happening. Sure if it's gonna be simulated the reaction that should take place. We should see some fumes. All right, so that chlorine should come off of this, but oh, it's actually gonna ask us to close the we have to close the acid. All right, I remember that's another thing too. We have to close the acid, because the acid can be contaminated with air. So that's a important precaution. A lot of precaution here, guys, for this lab. Trying to get the zoom here. All right, this now. All right, I think this thing here. You see this burgundy looking thing, guys?
yes, sir.
All right, what do you think is it? Do you think it is?
Sir, a container holding a harmful chemical, I think.
Yeah, but there's a sign on it. What does this sign mean?
Toxic waste, I think. I don't know.
Okay, yeah.
Something to do with chemicals, that's all I know.
Actually, yeah, it's actually mean disposable, disposal. It's almost saying something that should be disposed, a waste bin. So, all right, we clean the dropper. Just anything that's in the dropper, we just put it in there. It's a waste bin, really. All right, I think that's supposed to be almost like a semi-recycle icon there. All right, now guys, as you can see, the next thing that is being highlighted is NH4OH. All right, and for those of you who don't know, what is that?
I think ammonia hydroxide.
Yeah, ammonium hydroxide actually. So yeah, that's actually right. Also called aqueous ammonia. So we're gonna have to write down these reagents because they are not there. We have silver nitrate. All right, so we're gonna add ammonium hydroxide to that list, and you should recognize the formula because these are possible questions at CXE in terms of I'm expected to know that. So ammonium hydroxide has the formula NH4OH. All right, and then that is blinking at the moment. All right, so open it and let's step back so we can locate I think this is the we'll put the. All right, so this is supposed to be the rod, guys. This is the rod they're talking about, right? It's a stern rod. All right, if I can go over to it, if it allows me to, and you see that thing that's blinking now. Everybody seeing that?
Yes, sir.
Yes, sir.
All right, so stern rod, guys. All right, don't forget the name of that one, stern rod. All right, so when I use this, I'm going to dip it. Now let me just get a zoom. Okay, so it's held over there. It's interesting that we missed that one. We saw white fumes, but then we didn't get close enough to the reaction. Don't know if there's a replay that we can see what's happening there. All right, let's we should get white though. That's what we expect to see. And this was similar to the lab that we did. One of the first labs we did with the diffusion when we used the ammonia and we used the HCl and we saw the white fumes in the tube, right? So anytime ammonium chloride form, it's white. And that is telling us that chlorine is in there. So this is how we test for chlorine. All right. Add some. So we basically have like 4 tests for chlorine now, guys. 6, you just wanted to remember one of them. No, I'm doing like, let me see. For this lab, I'm actually gonna do 3 tests for them. The one that I wanted to remember though is the one with the silver nitrate. But then don't we think we might run out of time before that happens. So, but then the silver nitrate test is the most common one. As you can see, AgNO3. That will be the next chemical we're going to use there. All right, that's silver nitrate. All right, so let's just put the formula there so that when you go to write up your lab, you're going to recognize that is what it is. All right, silver nitrate, AgNO3 is coming up next. All right, this is blinking. Anybody knows why NH4OH is blinking?
Sir, for you to close it.
Yeah, very good. Very good. Yeah, for me to close it. So let's click on it and close it. And remember, ammonium hydroxide is something that can, like, you're supposed to know it's there already. It's like when you wipe your house with ammonia, it make the place smell, have this strong smell. All right. So, you have to be careful of this. Now, again, we're seeing the test tube as well. That's blinking. Put it over in the waste bin, and it's good now. All right. Any questions here, guys, so far? All right, this point.
No, sir.
All right. You think you understand what's happening?
Yes, sir.
Yes,
All right.
sir.
So we're just doing a series of tests. All right. That's how we're doing. Series of tests. So, all right. Let me just add this in. All right. So basically, what this is saying, and let me tell you, in backyard terms, right? This is saying if you want to make chlorine, if you want to see what real chlorine look like, all you need is some battery acid, car battery acid or truck battery. Get the acid that is in the battery. You get some of that. You get some salt from the kitchen. You get like a glass. You put some salt in the glass, and you open the battery and pour the acid and the salt in the glass, and then you would see some chlorine gas, forming. Now, remember, there are precautions when handling chlorine, guys. Chlorine is not very friendly. All right, chlorine was actually used as a weapon in World War I to kill off a large number of persons. All right, when the guns failed, they resorted to, it was chlorine and something else. Chlorine and another gas they mixed together, but chlorine was a part of it. Kill off millions of people, guys. So be careful with chlorine. All right. And it was around the same time there was a Spanish flu the year after, which was like almost like Corona today. So careful. All right. Now we're gonna do for the next step. See what we can do in 5 minutes here. I think let me just zoom out here. All right, this needs to be clean. So let's carry the stern rod over to it and it's clean. All right, glass rod is clean. Now we're gonna go to the next step. Let's just see what the next step is. Step 3 is where it is. We're gonna look at the precipitate now, guys. This is our first precipitation reaction. We're seeing the sodium chloride that's highlighted now. Let's get this out of the way. All right, again, we're using the spatula to take some of it and of course place it in the test tube. All right, and we are awaiting the we need to dissolve this, so waiting the highlighting. All right, anyway, let's just carry this over. Okay, so it's add, as usual, we add water to it, we shake to ensure that it dissolves. All right, seeing a lot of precautions that we need to record here. All right, so that's something. It dissolves now. We're gonna go for the silver nitrate. Very important compound in labs, guys, because this is used to test for anions. Many of them. In fact, the halogens is used to test for them. Adding that to it, do you notice any change in the test tube? This thing comes up fast. All right, let's go back again. F11. All right. What color are you seeing here, guys? Where the mouse is pointing?
Sir, white.
Yeah, white. Definitely, that's the white precipitate that's expected to form. So when you select white, it's certainly not blue or yellow, so it's white. So we're submitting that one. Formation would be silver chloride. Again, silver nitrate goes in, right, and it reacts with sodium chloride. So if I let me just switch the screen and show you how that looks like, guys. When we write it out. All right. So okay. Yeah, there you go. I'll get a drink for that. All right. So what we have here, silver nitrate is AgNO3. But you see that?
Yes, sir.
Yes, sir.
Good. We added, all right. So this was added to the sodium chloride. So we just want to write NaCl. Doesn't matter which one I write first though, but let's do it in this order. So silver nitrate was added to sodium chloride. Sodium chloride is NaCl. All right. Now, and this is how we write a chemical equation. So the plus means that we add it together, and the arrow means that something is being formed. Now, so what happens here? And there's a little story procedure to this as well. All right. What really happens here is that sodium replaces silver. All right. And silver replaces sodium. This is a chemical reaction. But you see that?
Yes, sir.
Right. So it's almost as if everybody stand up in a room, then and it's a party. We know that when the music start play, everybody is going to move towards the dance floor and probably peer up. All right, the same thing happened here. So sodium just takes away the partner from. Oh, by the way, I wonder you seen that. You seen the screen, right? With the reaction.
Yes, sir.
Oh, it's still there. Okay, and just so I know, say it's on the right screen. All right. So let me show you. Okay. Never mind that one. All right. So there we have it. All right. So now it's replaced now, guys. So silver will replace it. So when that happens, what would we write on this side now? So after the exchange now, if sodium takes the place of silver, what would be formed then? What would the name of the compound be?
Silver chloride.
Very good. They're gonna what sodium what?
Nitrate.
No, silver.
Sodium what? If sodium come over here, so
Sodium nitrate.
yes, it's gonna be sodium nitrate. Very good. So that's what we should have here. Sodium nitrate. Hope everybody is seeing that, you know.
Yes, sir.
All right. So this is a chemical reaction and writing an equation for the reaction. Sodium replaces silver, silver replaces sodium, and we have different new compounds being formed in the process, our new partners, new partnerships. So sodium nitrate is one of them. So sodium, we're gonna write that as NaNO3. All right. And then let's see if we can get some more space towards the right of the screen. All right. And if we have any NO3, when silver comes over here with chlorine, what compound will be formed?
Sir, silver chloride.
Right, so let's write down silver chloride because that's the name of the compound that's formed. Hope everybody's seeing the silver chloride is formed. Formula for silver chloride is gonna be AgCl. Everybody seeing that?
Yes, sir.
Yes, sir.
All right. So we won't go much further than here because time is up. So when we finish this lab next class, which is on Thursday, but this is just introducing you to formation of precipitate. I'll continue this next class. All right, guys.
Okay.
All right, see you in that time.
Okay, bye, sir.
All right, bye, Ariana.
Bye, sir.
Yeah, bye. All right.